Good morning. My name is Colin Doyle. I'm a Senior Systems Engineer at Juniper Networks. And today we're going to have a really quick video because my wife just sent me a text message saying that my son has just woken up. So a few minutes. We're going to talk about NTP. We're going to talk about Anycast, which essentially in this context means I have a LAN-side client that needs to do a time sync to an NTP server. I've got multiple NTP servers. That LAN client has to use a single IP address. So if one of those servers is unavailable, the other one is now providing information. We're going to do this using identical loopbacks on our servers. And we're going to do that using, in my lab, VMX routers to simulate these different devices. So I already have this all set up, so we're just going to really run quick through the config. I just closed a window on accident. In this diagram, we can see that I've got a VMX1 down here as a LAN client. I've got VMX2 as one of my edge NTP servers. I have VMX3 as my other NTP server. And my edge NTP servers are syncing with pool.ntp.org. And the VMX is syncing with a single IP address that exists on both of these devices. I'm using OSPF as my IGP, but this should work with BGP or anything else you care to use. And the CLI windows that are on the screen now do correspond with the location of these circles on this diagram. So we've got the client down here on the bottom, VMX2 here, VMX3 here. I already have this set up, like I said. I'll show you that now. I've got my show NTP associations. When you set an NTP server as pool.ntp.org, the router will resolve that Anycast DNS name to a IP address, and it'll put that IP address into the config. So you won't see pool.ntp.org in the config, you'll actually see the IP address that was resolved. So even though I gave these, when I was typing it out, identical configurations, you can see that they got different NTP server IPs that they resolved to. That's totally normal. They're also resolving to each other as an NTP peer. And this is just a redundancy bit of config that we do in Juniper so that, say, if one of these VMXs loses its connection to the internet or to that particular time server that it's connected to, it will continue to sync using this other NTP server peer that we have set up. So we start by assuming these are all connected and OSPF is working, which it is. If we show OSPF neighbor, you'll see that I've got full tables and all of this. So just trust that the underlay is set up right. And I picked an IP address for my loopback that would be identical in both VMX2 and VMX3 here. That just doesn't exist anywhere else in any of my lab environment. It's not routable to the internet. It only exists in this little pod. You can use whatever you want. Just be sensitive to where that, you don't want to be feeding that up into an internet routing table or anything like that. You want to use something public. So the two parts of this are the NTP configuration, which is done here under Systems NTP. And if I do a show, that's it. That's all the config I have. Be the same over here, configure, show system NTP. You can see that pool.ntp.org did resolve to a different IP. It's funny, you could do set server and you could use the identical command 2-3 times, and you'll end up with 3 separate IP addresses. And then we have this peer that's just pointing over here, and this one's just pointing back to it. If we do a show interfaces loopback, you'll see my 2 IPs. That first IP that you see there is the IP that is the true loopback. This would be my router ID as well. This would be where I'd be sourcing my protocols from. And then I have this identical IP on both. And if we look down here, you can see that this is the only NTP server that I actually have configured here. And it is syncing and it is working. Now, show route 172.17.0.1. We'll see both routes there. And I know right now that the preferred route is going here because I know where 30.22 is headed. That goes up to this device here. So if I were to say set interfaces GE000.30, actually just do this, disable, and do a commit, we should see that link go down here shortly once OSPF updates. Show. Oops. Show. Yep, neighbor. Turn off the wrong interface? I might have. Hang on. Show. Weirdo. Oh, you're not down. You're down. Took a little while for everything to catch up. So now if I do a show route, You'll see I only have the one option. It has switched over, show NTP associations, and I am on the other server. So that's it. That's all there is to it. I'm not saying there isn't more complexity. Certainly there's passwords you can put in, IP sourcing, and all that other stuff, but this is just the basic, get it running. And NTP isn't all that complicated. So, don't be afraid of how simple this configuration is. Likely there's not much more you need to do to this if you wanted to put it in production, unless you wanted to actually add in some passwords. Certainly if you're using the peer option, as you see up here, this peering is kind of one way. It can be initiated by anybody that is accepting peer connections. So having a peer password on actually ensures that people can't poison your NTP by just peering with you and maliciously connecting. So that's one thing. There's plenty of documentation. And please, if you have any questions, put them in the comments. Thanks.